Creating water from wastewater is one thing, and closely linked to that is creating other things of worth from wastewater. The term hydrothermal carbonization might sound as sci-fi as a stillsuit, but it's as real can be. Technology company Onunda is using hydrothermal carbonization to generate chemical energy in the form of gas and fertilizer from sewage. Onunda's CEO is Tom Samson, an energy engineer from Scotland in the UK, who recently had this conversation with Dr. Piers Clark.
Wonderful to be connected with you again. I think we last met, it was months ago, wasn't it? It was at the WWT conference in London. Is that right?
In February in London, yeah. That's the last time we met.
Where's it gone? Anyway, Onunda, what a great name. Am I pronouncing it correctly? And where did it come from?
Yes, you've got it spot on. Onunda. Its name is it's actually the Norse origins of how they named Windermere when the Vikings came to the UK. It means something along the lines of Great Lake or something along those lines. And Windermere is our origins. One of our shareholders lives in Windermere, and he had a technology company that he tasked with trying to tackle the sewage problem. And he basically asked the question, why can't we use technology to turn sewage from a problem into something that's got value? And so our origins come from Windermere, and so we thought we'd use that in our name. We're based in the Northwest. Our office is up in Cumbria, so that's where we came up with Onunda. It's kind of quite an international name. It sounds nice, and it does stick with you after a while once you get the hang of it.
And when you say Northwest, you mean the Northwest of the UK. It's one of the most beautiful parts of the UK, in some ways, the Lake District. All right, I've got it. Now, before we talk about the actual technology, tell me why. Why are you doing this?
Well, I think our purpose and our mission is really to try to transform how sewage and biosolids are dealt with in the industry, to try to effectively eradicate the environmental impacts that arise from the treatment and disposal of sewage and resultant biosolids. So that's really our purpose. It's to create a much more environmentally sustainable way for how we treat sewage and effectively extract all the energy, value, and nutrients that we can from the sludge and the sewage, such that there's nothing left that has to then be dealt with as a problem back in the environment.
So I've seen a graph, a Venn diagram, very clever Venn diagram with 3 balls. Just walk me through that.
Yeah, this is a Venn diagram that comes from the UK Bioresources Strategy that was issued last year, July 2023. And what it shows is the trends where regulations, global trends, are moving away from traditionally returning biosolids back to land or incineration. And there's a demand, there's a drive for this green circle here is new technologies and innovative ways in how we can treat sewage and sludge. And Onunda, we see Onunda sits clearly in that green circle.
And it's that green circle where it's treating them and them not going to agriculture, not being recycled to agriculture.
Yes, so the green circle is where you've got solutions, technologies that neither have to return the biosolids to land for agriculture, nor incinerate them or return them to landfill. So that's the space. And we see there's quite a lot of opportunity in that space. There are not any other solutions that we're aware of today that fully extract all the energy, value, and nutrients and have zero resultant byproducts going back to the environment.
All right, now we've got a sense of what it is, where you fit and why you're doing it. Talk me through the actual process. So what is the Onunda process?
So the Onunda process really is combining traditional technologies that exist today, which is really our dewatering and drying technologies with our specific gasification technology, with innovative, more advanced technologies on the front end, high temperature destruction, high pressure environment, hydrothermal carbonization, of treating the sludge such that we can destroy the forever chemicals and microplastics and the pathogens under pressure and temperature. And so it's how we combine those 3 processes in an integrated manner where we maximize the recovery of energy and heat between those 3 systems, and we produce byproducts that have got a value or a worth that can be used in other applications. So that's essentially what Onunda does.
And those byproducts are?
So the first byproduct is when we do the dewatering stage, we've created a high nutrient liquid, which is basically free of any plastics or micro chemicals or pathogens. PFAS, yeah, exactly. It's free from all that, but it has some nutrients in it that can have two applications. That can be fed back into anaerobic digesters to boost biogas production, which is a really exciting opportunity if we're integrating this with existing wastewater treatment facilities. Or it has other applications given its nutrient level for hydroponics or other fertilizer applications. The next byproduct is the syngas. Now, most of the syngas is used to heat the process as combustion energy. So all the energy needed for Onunda technology is coming from the syngas released from the sludge.
Okay, so it doesn't need any external energy source.
No external.
No hydrocarbons need to be burnt in the production of these byproducts.
None whatsoever. And so we've again produced residue from the gasifier then, where we've produced the syngas that has applications as a supplement for making cement, supplement and manufacturing additive for making bricks, but also has still a lot of nutrients in it. And at this stage, it's a dry, soluble powder. So it has phosphates and nitrates, so it still has a fertilizer application, but in a much more manageable and controllable manner than sludge in itself. And clearly then we have excess syngas, and that excess syngas can be used to provide clean electricity, and that can actually power most of the energy load, the electricity demand for the wastewater works as well on top of that. So it's a very, very sustainable and environmentally friendly and emission-free solution.
Excellent. Now, tell me, where are you at in your journey? You haven't yet got a full-scale installation, is that correct?
So our first approach is to put in place a pilot project. Now, we've got high technology development on the dewatering and the gasification technology. That's been built before. We're working with Newcastle University on the R&D for the hydrothermal carbonization that's customized for the sludge to create the char for our gasifier. So that piece of work is underway with Newcastle University. But we're now looking at a pilot project application that's about 1/10 of the commercial scale. And that pilot project will be funded by Onunda. We're in the process of raising capital at Onunda right now in the form of a loan. We're pursuing loans that are impact funding for companies that are having a positive impact on the United Nations Sustainable Development Goals. So once we've secured that funding, we'll be in a position to finance our first pilot project. And we're working with counterparties in the Middle East on that first pilot project being deployed as soon as that funding's available.
Brilliant. Tom, I wish you the very best.
Thank you, Tom and Piers. So, destruction of microplastics, destruction of PFAS, production of synthetic gas, syngas for power, and production of nutrients for agriculture, all powered entirely by renewable energy. We will be following Onunda's pilot projects with great interest, and of course we'll ask Tom back for an update.